If you scroll through the photos that the Perseverance rover sends us from the frigid desert of Mars, you're going to find hundreds of pictures of this. It's a calibration target that helps adjust the colors for one of the cameras. And if you look really closely, you can see a tiny message printed on the side.
Are we alone? Are we alone? We came here to look for signs of life and to collect samples of Mars for study on Earth.
That's the mission, and that's the question that Percy was designed to answer. It's a question that has driven so much of our exploration of Mars. And the thing that's driving me kind of crazy is that we may have already found an answer, but we just have no way to check. See, that rover is carrying tubes that it filled with Martian rocks. And one of those tubes, sample number 25, holds what may be the most promising evidence we have from anywhere in space that something has lived somewhere other than here.
We were really like, whoa, this is very exciting.
In this episode, we're looking at what Percy discovered on that rock. We'll explain what it took to find sample 25 and why its potentially paradigm-shifting evidence is currently stranded on the surface of Mars.
If we were to find life on Mars, even microbial life, it means that out of 8 planets, 2 of them. That's a lot. 2 out of 8. Now you multiply that, by the billions and billions and billions of planets that we have only in our Milky Ways.
One of the big changes in the last couple decades has been we went from sort of wondering how many of these stars that we can see, billions and billions of stars, how many of them have planets? And it sort of seems like they all have planets, which increases. That means there's billions and billions of planets now.
It's actually a trillion, which might as well be like a bajillion, gazillion.
Yeah. It's an incomprehensible amount of places that life could be.
Incomprehensible.
Yeah, and that's why it's they've got to be somewhere.
Yes.
They've got to be somewhere.
And yet, we have no proof of even a single cell out there.
Mm-hmm.
But we have this next door neighbor. And as soon as we could, we went to see if Mars was habitable. At first, it seemed like the answer was no. For thousands of years, Mars was this little point in the night sky. Telescopes revealed a ball with blotches that some thought were canals built by an alien race. So think about how exciting it was when NASA sent the first spacecraft to fly by Mars for a closer look. They had no idea what they would find there. Mariner 4 could capture 21 images. Each one took hours to transmit back to Earth. And when they finally saw Mars, they were stunned to find that it looked like the moon. They didn't realize that their spacecraft had missed the most interesting areas. All they saw was a planet that was cratered and completely unalive.
It may just be that life, as we know it, is more unique than many have thought.
Fortunately, NASA kept flinging bots at Mars, spurred on by geopolitical competition. And the next challenge was to insert a spacecraft into orbit and scan the rest of the planet. That's when they could see that water once flowed across the surface in huge rivers that carved canyons. And that's important because there are 3 main things that an environment needs in order to be habitable for life as we know it. And the first one is liquid water. Now, Mars' surface pressure is so low that water would vaporize unless it's buried underground or under ice. But rewind a few billion years, and it seems Mars was once more Earth-like. After the orbiters revealed where the water once stood, NASA started putting robots on the surface. First came landers that could only study the soil nearby. Then rovers with their wheels and drills to seek out the kind of rocks that keep good records. And those rovers checked off the other 2 requirements for past habitability. They found all of the elements needed to build life, and they found an energy source to power life. And this part is important if you want to understand what's in that sample tube. Have you ever heard this quote, that life is nothing but an electron looking for a place to rest?
No, I haven't, but I like it.
At the most basic level, living things get energy by providing a shortcut for electrons to move from something that's loaded up with them that wants to give them up to something hungry to receive them. For us, that receiver is oxygen. It's why we need to breathe. The donor is our carbon-rich food. And as each electron moves to its resting place, our cells harvest some energy. Microbes can do this without oxygen. Instead, they can use elements like iron and sulfur. And in 2013, a rover called Curiosity found electron donors and receivers together in a Martian lake bed, showing that there were at least some places where microbial life could have thrived on Mars. So the way that they describe it is that it's like finding a battery, and we don't know if anything used it, but we know that it was there to be had.
The kind of gradient that we might see in a Earth environment where it was just like bacteria that don't use oxygen or photosynthesis.
Right. So decades of exploration established that Mars was once habitable. But did anything actually live in that water and use that battery? That's what Perseverance was sent to find out. In July 2020, the world had shut down, but somehow the team at NASA was still able to get Percy ready to leave Earth. They added a plaque to commemorate healthcare workers and sent the rover on a 7-month flight through space. Now, the previous generation of rovers was basically bubble-wrapped and bounced onto the surface, but Curiosity and Perseverance were too big for airbags. Instead, after a parachute slowed it down, the rover was lowered on cables from a platform with retro rockets. This is a system called Sky Crane, and incredibly, they captured it all on camera.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Its destination was the western edge of a 45-kilometer impact basin called Jezero Crater.
It looks like there's a river coming into the crater off to the left, and then almost like a delta where like sediment has sort of fanned out into the crater from the mouth of that river.
Exactly, yes.
Whoa, this is cool. It looks like there's a couple rivers.
Yes.
There's one on the right side too.
And the one on the right side is an outflow channel.
Oh, okay.
So we're not just talking about, a river that came in but then dried up immediately.
Yeah.
This was once a lake. Sites like this have rocks that formed from layers of fine-grained dirt settling underwater, which is one of the best ways to preserve records of the distant past. This timeline shows the age of the rocks that Percy was sent to explore. That overlaps with the period when Mars was most likely habitable on the surface, because there was water sitting around. That's before the atmosphere thinned out, which they attribute to the loss of the magnetic field.
It's also sort of the same time that life was evolving on Earth.
Right. The weird elephant in the room is that we don't know when, how, or where life arose on Earth. So it's like, well, why don't you figure that out before you go and look for it on Mars? But there's a reason that we can't see that far on our planet.
Mm-hmm. Right. Tectonic movement is chewing up the surface all the time. Rocks are getting recycled. Like, yeah, that's another element of this, is that we can actually learn something maybe about how life evolved on Earth if we could find these early signs on Mars.
Looks like we're getting the first image.
The rover tested its equipment and recorded the first sounds from Mars. It deployed a helicopter, the first ever to fly in the sparse Martian air. And then, Percy was ready to start collecting rocks. This one was collected on accident. After working for almost a whole Martian year, Percy had 18 samples and dropped 10 of those on the ground in a zigzag pattern near the base of the delta. These are backup tubes that a future mission could collect with a helicopter if they can't access the rover itself. But the most interesting sample hadn't been found yet. On Sol 1159, Percy entered Neretva Vallis, the river channel that leads into the crater. It took a path in between dunes toward an area of light-colored rocks, and then right there, it found what we sent that rover to find. See those weird spots? They're the leftovers from a certain kind of chemical reaction.
So we got those pictures down, and we immediately knew that there was something different and interesting in these rocks.
They kept the rover near that rock for the next few weeks, taking as many measurements as they could, and then pulled out the drill to grab sample 25. Now, as Percy continues exploring outside the crater, it's carrying a tube that may hold one of the biggest discoveries of all time. But before we look closer at that sample, I want to run a quick test. Mars isn't the only place in the solar system that might host life. Some other promising candidates are these icy moons. First, there's Europa. Second, Enceladus. And third, Triton. Wait, did I say Triton? I meant Titan. This is the result from WhisperFlow, which is a really smart voice-to-text tool that I can use inside any app, compared to the built-in dictation tool on my phone, which has never heard of Saturn's 6th largest moon. I also timed how long it took to type that on my keyboard, where I'm pretty fast, and on my phone with my slow millennial thumbs. WhisperFlow beats them by a mile, and I don't have to spend as much time fixing mistakes. To use it on my laptop, I just hold down the function key, and I can start dictating in Slack or Docs or Gmail, wherever I'm working. WhisperFlow is free to use, but you can get 1 month of WhisperFlow Pro with unlimited words if you use the link in our description or type in the promo code HowTown in the settings on desktop. Okay, let's get back to that tantalizing sample that Perseverance is carrying right now. How bad do you want that tube?
Really badly. So much of what we do with NASA science is driven towards answering the question, are we alone in the universe? And maybe this sample that we've got inside the belly of Perseverance holds the answer to that question, which would be, I think, sort of, we would answer a question that humanity has been asking for since the first time we looked up at the night sky.
So what exactly did they find on that rock in the river channel leading to the crater? NASA calls these marks leopard spots, and to give you a sense of the scale, this region is about the size of a matchstick. The spots are 1 millimeter or less across. Joel and his team used an X-ray at the end of Percy's robotic arm to scan the rock bit by bit and map the elements it contains. The red is the iron in the mud that formed the stone. Blue is phosphorus and green is sulfur. Another instrument found organic matter in this same rock.
There was a chemical reaction taking place between the rusty red mud and the organic matter that was making, as a byproduct of that reaction, the iron and phosphorus bearing minerals and the iron and sulfur bearing minerals.
I'm a little confused.
Okay.
You said there's organic matter in this mud.
Mm-hmm.
But isn't organic matter just defined as like carbon compounds that come from life?
No,
already?
No, not necessarily.
Oh, okay.
There are non-living sources of organic matter.
Gotcha.
For our purposes, finding organic matter in that rock is significant because it could have been a source of a meal for microbes. Whether it was from life or not, it's something that life could have made use of as a source of these electrons. Remember how we get energy by moving electrons to oxygen? Well, that's not the end of the story. When an electron lands, it transforms whatever caught it. And when it lands in the rusty iron in the mud, that iron can dissolve in water, leaving a pale spot. Then it can link up with phosphate and leave these dark mineral outlines. This could be the product of microbial metabolism, or there are other pathways for that reaction that don't involve life. But then there's this other mineral here, the iron sulfide at the center of the spots. You can get that mineral if microbes use up the nearby iron and move electrons to sulfate instead. Without life, that reaction would require intense heat, and they see no sign that this rock was ever that hot. So right now, based on what we know, if these marks were not made by microbes, scientists don't know how to explain them.
Mm-hmm. Okay, so that's pretty exciting.
We should be falling over ourselves to get that potential biosignature back. I'm not saying it's life. We don't know if it's life. All they can say from this instrumentation they have on the rover is that if you saw this on Earth, it would be a creation of life.
NASA's not going around saying, we found evidence of ancient life on Mars, because geology and chemistry can create forms that look like biology, but aren't. In the 90s, there were some scientists who looked at this meteorite.
I remember this.
If this discovery is confirmed, it will surely be one of the most stunning insights into our universe that science has ever uncovered.
It turns out that you don't need life to explain what they saw on that meteorite. So now they don't want to make big proclamations until they can bring sample 25 back and do more tests on Earth.
But where do you go from there? Like, what would more tests that we would do on Earth even get us from these samples?
You could take the iron in the mud and the iron phosphate and measure the isotopic composition of the iron in those two materials. When biology is involved in turning iron from one material into another material, it changes the isotopic pattern or the isotopic composition of the iron in ways that are like expected for biology and expected for not biology.
They could do the same analysis on the forms of sulfur in the leopard spots versus the mud. And life leaves other patterns, like the even-numbered carbon chains in the membranes of cells, which they can check for.
But why can't we just do the science we need to do on the surface of the planet?
Basically, to reach that level of certainty of confirmation, we need to use the most precise nanoscale resolution instruments that we have. And some of these things are like the size of a car or the size of a building. And so there are versions of them that you can do on Mars. They're just going to give you probably more ambiguous results that you can't replicate.
And you're saying like this, the scientists that you've talked to are basically saying, if we could just get these samples back to Earth, we would most likely get a definitive answer about whether or not they contain signs of life.
Yes. Yeah.
Okay. That's exciting.
Mm-hmm. Except for we can't get them.
Except we can't get them. Right.
Perseverance was supposed to be the first step in a flagship mission to return samples from Mars, which has been listed as the highest scientific priority in planetary science for 20 years, and a broader goal of NASA's dating back to the 70s. But in 2026, after realizing what it was going to take, the US government effectively canceled that plan. This is how it was supposed to happen. Mars sample return was going to require at least 8 different actions, maneuvers, that had just never been done before. So as we watch the trailer, we'll go through each of them.
Okay.
There's Percy.
There it is, looking up.
And this would be the largest thing to ever land on Mars. It needs to touch down in a super precise location. It would be the first transfer of samples from one vehicle on Mars to another.
Pretty cool. Whoa.
The first rocket to launch off another planet.
Ballistic missile, basically.
The first autonomous rendezvous and capture in orbit around Mars.
Wow.
The first robotic sample handling and sealing to remove Martian dirt. The first departure from Mars orbit for return to Earth. And then the first restricted entry and landing of extraterrestrial samples.
Pretty complicated.
Yes.
A lot of steps, a lot of different vehicles.
NASA and the European Space Agency were supposed to team up on this to launch in 2028 and get the samples back by 2031, but they could not make it work. What is the best way to understand why this was canceled?
Money. It started to become too expensive. This is kind of the interesting tension. Do you want NASA to do things it's never done before? The more things you've never done before, the bigger risk there is in terms of cost, because you don't have any historical examples of how to plan for that, what it should or shouldn't cost.
We've already spent $2.7 billion on Perseverance and a couple billion more developing the return mission, which a 2023 report estimated would cost $8 to $11 billion, doubling an earlier estimate. That's a lot less than the Artemis program to send astronauts back to the moon, but it's still in the range of NASA's most expensive science missions, the Hubble and Webb space telescopes.
You didn't have enough money to do that and maintain your other science programs.
NASA's documents suggest that the biggest engineering challenge was the rocket. It needs to resist bending while decelerating onto Mars, laying sideways in the lander, then sit on the frozen surface for months with fuels that require climate control, and then work perfectly on its only launch attempt and place the samples at a specific altitude where the orbiter could capture them. This can't be tested in advance under Mars-like conditions, and there's no one to swap apart if anything breaks. There were lots of other design delays, like this system for grabbing the sample container from orbit, sterilizing it, and sealing it in another container.
Because there's a non-zero chance that there maybe is some microbial life on Mars, the standards for handling that, it's like a CDC kind of, clean room where you're working with an infectious disease, that started getting really, really complex and very burdensome.
I am not a fan of sample return, to tell you the truth. I think that they are extremely expensive missions. Having said that, because we put all of this investment in time and iterative missions building on each other. And now we have the right team, the right rover, and the right rocks. And we're saying we are not bringing them back? I don't think this makes any sense.
After these leopard spots were published in a paper, NASA held a press conference, and the timing was a little awkward. It came a few months after the president's budget request zeroed out Mars sample return. And so when they opened up for questions, all these reporters were like, okay, you got this really promising sample, like what are we going to get it? What are we doing?
Yeah.
I would say, no, listen, we are about manned exploration. Human exploration. We don't want to just bring samples back from Mars. We want to send our boots to the moon and to Mars.
If sample return gets another chance, it may be as part of a broader strategy towards sending our boots to Mars.
If there's one thing that humans need when they go to Mars, they need to come back. What a perfect opportunity for Mars sample return. Don't put a human on that first mission, bring the rocks back. And so there's lots of different ways to approach this that haven't really been pursued. We just need to have the effort and motivation to do it.
Within the next 10 years, Percy's nuclear power source will degrade. It might need to drop sample number 25 in an accessible location or go into some kind of sleep mode until we get back there. In the meantime, China has its own sample return mission planned, and they have recent experience doing this on the moon. Their lander will reportedly have a drill that can reach a depth of 2 meters, where biosignatures may be better preserved. Europe is also planning to put a rover on Mars in the early 2030s. It won't be sending samples home, but it will also have a 2-meter drill and a highly sensitive instrument for analyzing organic molecules. Perhaps the life-changing discovery of a biosignature on Mars won't come from a NASA mission.
If there's life on Mars, that changes the entire game to me. If there's life on our planet, we know for sure. That's number one. Yes. And if the next place we look, there's life, that just suggests to me that of course there's life everywhere else, that it's not rare, that it's actually going to be very common to find.
There's one wrinkle to that, though.
Yeah.
Mars and Earth exchanged a lot of rocks earlier in their history.
Right. That would be the next big question is, did this life evolve independently?
The astrobiologist that I talked to told me that if there was life billions of years ago on Mars, it's probably still there. Because what we've learned about life is that it is so persistent.
Tenacious, yeah.
That was really exciting to me because it's not just about ancient microbes. If we confirm that there were ancient microbes, then you want to start looking for the ones that are still there.
Right, drilling into the ice caps, drilling under these ancient riverbeds where there might be some kind of groundwater situation. All this would be so exciting. It feels like in our lifetimes, this is possible.
I was just going to say, I hope I'm still alive when we figure this out.
Here's hoping.
If you want to know who's behind this channel, it's me and Adam and Charlie. There's just 3 of us trying to make this really in-depth independent science journalism work on YouTube, and we really need your help. So please sign up at patreon.com/howtown to join our community and help us keep making these videos for as long as we can.